Welcome back to another explainer. So, if you've been working with React for a little while, you've definitely got the basics down, right? You know your components, you get state, you completely understand props. But today we are taking a massive leap forward. We're going to dive deep into the Advanced React Toolkit, unpacking 12 core concepts that are absolutely going to elevate your dev skills from just standard to completely extraordinary.
It really begs the question, doesn't it? What exactly separates a beginner React developer from a true, highly sought-after expert? Well, it's definitely not just memorizing more syntax by heart. The real answer lies in moving way beyond those surface-level basics and truly mastering the advanced, under-the-hood concepts. It's about fundamentally understanding exactly how React operates behind the scenes so you can build apps that are resilient, highly scalable, and most importantly, incredibly fast. Okay, let's dive into this. Here is our roadmap for today's journey. We'll start with boosting app performance, then move into managing UI and errors. From there, we'll hit advanced component patterns, and finally, we'll go deep under the React hood.
First up, Section 1, boosting app performance. It's all about making those applications lightning fast for the user.
You know, in modern web dev, speed isn't just some nice-to-have luxury anymore. It's an absolute requirement if you want to retain your users. So we've got a sequential flow of 3 brilliant concepts to make that happen: code splitting, lazy loading, and suspense. Think of your web app like a massive, heavy encyclopedia. Instead of forcing the user to download the whole giant book before reading page 1, code splitting automatically breaks the app down into smaller, bite-sized chapters. Then, lazy loading steps in. It literally delays loading those specific chapters until the exact millisecond the user actually clicks on them and needs them. But okay, what happens during that tiny delay? That's exactly where suspense shines. It elegantly handles that loading state. Maybe it shows a sleek spinner or a skeleton screen, just making sure the experience remains totally seamless and beautiful for the user. Honestly, they work together as this perfect high-performance trio.
Now, what about the components that are already sitting right there on the screen? Enter React.memo. What's really interesting here is how it acts as a performance optimization tool, specifically preventing a component from needlessly re-rendering if its props haven't actually changed. You can think of React.memo like a highly efficient bouncer at the door of your component. Every single time React wants to update the screen, this bouncer checks the incoming data, the props, to see if they're actually different from the last time. If nothing changed, the bouncer says nope and stops the update right in its tracks. It's essentially a shield, saving precious processing power and keeping your app incredibly snappy by stopping those unnecessary UI updates. Moving right along to Section 2, managing UI and errors. This is where we focus on keeping the interface stable and flexible.
So we're pivoting a bit from pure speed optimization to handling the absolute unexpected. Because, let's face it, we can optimize for speed all day long, but what happens if a component just flat out fails to load? What if there's corrupted data coming from your back end? Or some sudden, completely unpredictable network error? We've all been there, watching a beautifully designed web app suddenly crash into a terrifying blank white screen just because one tiny piece of the UI broke.
And that is exactly where our next critical tool comes to the rescue: error boundaries. These are specialized components that catch JavaScript errors anywhere in their child component tree. They log those errors and then display a friendly fallback UI instead of crashing the whole shebang. They're an absolutely vital safety net to have in your developer toolbelt. Imagine an error boundary as a quarantine zone. If a random widget on your sidebar breaks, the error boundary contains the crash strictly to that one specific widget, showing a polite, "oops, something went wrong" message. Meanwhile, the rest of your application just keeps running perfectly fine. It literally prevents one broken component from sinking the entire ship.
Next up, for managing our UI, we have portals. The big idea here is that portals allow you to render children into a completely different part of the DOM, entirely outside of their parent component's hierarchy. Look, if you've ever tried to build a custom modal, a pop-up dialog, or one of those tricky hover tooltips, you know the absolute nightmare of overlapping UI elements, hidden overflows, and those endless z-index wars. Portals solve this brilliantly. They let your component safely break free from its restrictive parent container and render right at the root level of your document. This guarantees your modal always sits perfectly on top of everything else, exactly the way you intended, all while keeping your underlying React code beautifully organized.
All right, Section 3, Advanced Component Patterns. Time to talk about organizing complex app logic.
As your applications grow larger and way more ambitious, you're going to hit a major wall. How do you share the exact same behavior or logic across completely different components without basically duplicating all your code and creating a massive maintenance nightmare? Well, this brilliantly illustrates two contrasting historical architectural patterns for solving that exact problem. On one side, we have render props. This involves sharing code using a prop whose value is literally a function. It's super dynamic, letting you pass a rendering function down into a component to dictate exactly what it should display. On the flip side, we have higher order components, or HOCs. An HOC is essentially a function that takes an existing component and returns a brand new, supercharged component with extra logic wrapped around it. Now sure, modern React relies heavily on hooks for a lot of this today, but understanding these two advanced patterns, it's absolutely essential for reading complex, enterprise-level code bases and really mastering the structural flexibility that React gives you.
Which brings us to Section 4, Under the React Hood. Welcome to the engine room.
You can consider this your VIP backstage pass to React's brain. And we're starting with reconciliation. This is React's algorithmic process for diffing one tree with another to determine exactly which parts need to change. The crucial point here is this. When your data updates, React doesn't just blindly redraw the entire web page. That would be incredibly slow and resource-heavy. Instead, it creates a new virtual representation in memory, compares it to the old one, that's the diffing part, and then calculates the absolute bare minimum number of changes required. Reconciliation is essentially the mathematical brain figuring out exactly what needs to update on the screen as efficiently as humanly possible.
But to make reconciliation even faster and more fluid, React actually had to undergo a massive internal engine rewrite a few years back. And that rewrite is known as the Fiber architecture. Fiber is React's core rendering engine, designed specifically to enable incremental rendering of the virtual DOM. You see, before Fiber, React would start updating components and literally couldn't stop until it was finished. On heavy, complex apps, that could completely freeze up the screen. Fiber changes the game by breaking that rendering work down into tiny, manageable chunks. It gives React the superpower to prioritize work, letting it pause less important background updates so it can immediately handle high-priority stuff like user clicks or buttery smooth animations.
And because of that foundational Fiber engine, React was able to unlock two revolutionary advanced rendering capabilities: concurrent rendering and server components. Concurrent rendering takes full advantage of Fiber. It allows React to literally pause a heavy rendering task running in the background, update the UI so it stays completely responsive to the user, and then seamlessly resume that background work later. It's literally what makes modern apps feel so incredibly smooth. Server components, on the other hand, push the boundary entirely. They allow your components to execute completely on the server, fetching data right next to your database and sending absolutely zero JavaScript down to the client browser. I'm telling you, it is an absolute game changer for loading speeds and overall performance.
Wow, okay, we've covered a massive amount of ground today. This really maps out your fully loaded advanced React tool belt. Take a mental snapshot of this. Under speed and efficiency, you've got React Memo, lazy loading, suspense, and code splitting, all working together to keep your app lightning fast. Under architecture, you've got error boundaries, portals, render props, and HOCs keeping your UI beautifully stable and your logic perfectly organized. And finally, driving the whole thing is the core engine, powered by reconciliation, the Fiber architecture, concurrent rendering, and those revolutionary server components. But, understanding these tools conceptually is one thing. Actually applying them is where the real magic happens. So, I want to leave you with this final provocative thought. How will you implement these 12 advanced techniques in your next build? I really challenge you to take these concepts right out of the engine room and apply them to build world-class, lightning-fast modern web applications. Keep learning, keep pushing the boundaries of what you can build, and I will see you in the next explainer.